Morning and welcome to the Friday talk show of Global Electronics. And this is your host, Rajiv Kulkarni, once again bringing you another topic. I would say it is a topic of feed forward and uh, feedback. Uh, it is session 2.0. Yes, we already have done one session on this, and today we are going to do 2.0. And as we all know that in the electronics manufacturing, so many activities are happening in today's world. And the densification of the circuits, the design of the circuits being continuously getting upgraded or updating, and the designs are becoming more and more dense because of the requirement of the intelligence, I think, circuits in the system. Let's say if we are talking about automotive electronics, for example, we have multiple electronics gadgets in the automotive, right? When you drive a car, you have so many activities are happening, and everything happens through the electronics. And because of that, the densification is increasing, where we have very high density circuits, and also a lot of intelligent chips are being designed and being implemented or being used in the circuits. So basically designed for assembly principles, it plays a very crucial role in optimizing miniature component assembly and by simplifying product structures and also reducing part counts and enhancing manufacturability. Feedback and feed forward mechanisms in design for assembly help refine assembly processes by identifying inefficiencies and proactively addressing potential challenges. So we have very interesting topic here today, and to discuss that in length, we have Mr. Ambaprasad. He is a technology expert based in Bangalore, Karnataka state in India. Bangalore is supposedly be the Silicon Valley of India, and where you have the high-tech engineers coming out every year, and also we have very high-tech companies, design houses based out in Bangalore. So Ambaprasad, with his 3.5 to 4 decade rich experience in the design industry, in the electronics industry, especially in the manufacturability as well as design. So we have with us today Mr. Ambaprasad. Welcome to the show, and good evening. How are you today, sir?
Yeah, doing good.
Very good, very
Slide
good.
39. Yeah,
And
38.
I'm going to now share some of the slides, and so that we can walk through that slide and talk about our activities today. Just give me 1 minute here. So I keep the slide open. Are you able to see my screen?
Yes, yes, yes. Go
I
to
will
full
enhance that.
screen mode.
Yes.
Yeah, nice.
Okay, great. And yes, Amba Prasad, before we jump onto the slide, can you just give you some background for the for our audience about the what is feedback and feed forward mechanisms in DFA?
Uh, yeah, almost. I can liberally say more than 90% of our audience are already aware what is feedback. It was there long, long ago. You do a design and you go for manufacturing. And in manufacturing, the manufacturer will give a feedback telling that certain components they're not able to mount or they're not able to meet certain parametrics, or that is feedback. You take care of in the next revision. But when we say feed forward means through design, proactively, we control things and we say to what extent you can tune, and then we freeze stack ups and we freeze sort of termination values and things like that. And we tell the manufacturer to what extent they can tune and what extent they cannot go beyond the process window. So that is feed forward. Feed forward is fixed. based on a PDKs and ADKs given by the semiconductor fab houses. And when we were talking about introduction of the session, you were talking about electronics in automotive, right?
Yes.
40 years back, the only electronics in automotive was the car radio. Maybe
Yes.
the buses had TV for entertainment.
Yes.
At least in India, we had video coaches where people used to
Yes.
watch TV and go. But today,
And that would cost more
yeah,
than the non-video buses. Yes.
yeah. And today, when we say a car, we can very loosely express a car is a computer with wheels. Okay. So that has got so much of compute.
Right. Right.
Latency is as important in ADAS as much as it is in any high performance computer. Yeah, yeah. In this slide, in the previous session, we told what are the defects we can find in assembly of a BGA component, a bump size going from say right, left to right, and the standoff height. Especially, it is very critical in low profile components. And the tilting, it will actually the schematic here is showing tilting left or right, but actually a BGA can tilt in any 360 degrees, and it is not
Hmm.
that. And one set of balls can tilt in the left and the other set of balls can tilt in the right at the same time. It's a nightmare scenario. It's a total defect, okay, which leads to failure. And head and pillow, this is another defect. Basically, the connection is not made. Go to next slide, please. Yeah. Uh, this is the latest slide which we are talking about a product life cycle. Again, a product goes through a lot of, there is research and development.
Yeah.
Product is conceptualized, models are made, product is built. Okay, I mean, of course, we talk about PCBs, even mechanical enclosures are built actually. Then there is a technological valley of death. So people don't know what to do.
Hmm.
They try to do something because somebody else have done it already, and it may or
Right.
may not fit in. That is where most of the concepts fail. It's a
Right. Right.
sort of once you surpass that, you go to field and demonstration, and again here we are seeing a commercialization valley of death. Maybe the product you have made is too costly. Okay. Or maybe you made a product which is too cheap, but your customers think why it is so cheap. I mean, when we say luxury, people think luxury means it is more cost. Okay. If somebody starts selling Apple phones at a throwaway price, believe me, nobody will buy it. They think something is gone wrong there. Okay. These are the things. And then there is a scale up and commercial launch. That is where you hit the industry. That is a long cycle. People start making profits and all, and then you start deployment, and then market transformation. So here
Hmm.
there are technology readiness levels, uh, and it is actually 1 to 9. And when you say you're in a technology level 9, you can also manufacture, and anybody else can manufacture. You can technology transfer it to your partners or across the globe. And then again, there are material readiness levels. There is organizational readiness level, staff readiness levels. There are so many levels are there. So these levels, it shows the maturity level actually. And again, there are risks. There are certain risks you have to take. And there are some challenges you cannot cross. You do whatever. You cannot do it. Nobody can do it. And maybe
Correct.
your marketing team might have told, yes, we can do it, but it may not be possible in such and such a short time or such and such a cost. So these are all the challenges companies face. But once they hit a TRL 9 and above, it's a stable life. Product can be deployed without any problem. And this is where at every stage, your feed forward and feedback will come into picture. Can you go to next slide, please?
Yeah, before that, you said that when product reaches a TRL 9, so
Yeah,
it is like a, smooth, forward, right?
yeah.
But who decides that? Like, are there any certain bodies or certain technology auditing body that, yeah, product is now at this?
Yeah, yeah, okay. For example, there are roadmaps available.
Yeah.
The roadmaps will say what is going to happen this year and after 2 years and after 5 years and after 10 years. So
Yeah.
probably if you say, when you do a product, let's say you do a nice server or something, okay, yeah, server, you invested heavily on that.
Right.
Your company has invested. They want to make
Right.
as much profit as possible. So what happens is the
Right.
technology what they are following, the assembly, the process what they are following is under patent. Nobody else
Yeah.
can manufacture. Okay, that's where it
Okay.
stops. But once
Okay.
the technology goes forward, it's transferred everywhere. In fact, you remember about 20 years back, we had a laminate called as a polyclad turbo, which used to be a 2
Yes.
mil laminate where VCC ground shot was not happening. Only in that
Yes.
polyclad turbo, actually even the polyclad turbo market, the name went out of the market. It was taken by some other company. And every company who used this, they used to pay money for them. They made a lot of money out
Correct.
of that. Yeah, so
Correct.
this is where TRL for one product, let's say TRL is a stage. You can surmount TRLs, you can go to next level, maybe in 1 year, or maybe in 3 years, or maybe in 5 years. Depends on the market maturity and material readiness. So maybe we may be using a particular material and we block others from using it. We means as an
Got it.
industry. Some country may use, some country may not license to be used in some other country, especially if this happens in defense and aerospace.
Very well said. Very well said. Okay.
Feedback and feed forward data management. Now, when we say a product design, especially electronics, high end, even your assembly process starts in the design itself. The decisions are taken upstream. Okay, this is called as shift left. Whatever decisions we are supposed to take at the assembly level, we take on the design level itself. And we
Hmm.
freeze certain parameters and we give the feed this data to our assemblers, telling that this is what you have to do. This can be a digital through a digital twin, or it can be through NDA, whatever it is. But your EMS houses will be ready with the dummy runs or a trial runs even before they hit the actual component. Okay. Design data, we are going to share CAD files, manufacturing data, machine settings, process parameters, inspection criteria. Nowadays, inspection is only through AI. I mean, inspecting through, when we say inspection, don't think inspection using a field glass or a magnifier. Those days are gone. Now everything is through AI. And assembly data, component placement, soldering profiles, solder paste inspection. These are testing results, maybe flying probes, all. AI models, everything is through AI. It
Yes.
is totally driven
Yeah.
by AI.
That
Okay.
is true.
And embedded components, people are putting components inside the PCBs. Even people are putting active components. They are putting ICs inside the PCBs.
Hmm.
Next slide, please. Feedback in data management. What do you mean by feedback? Feedback, I told earlier. Feedback involves using past data. Revision 1 is worked. We had a problem. In revision 2, we fixed those problems. That is feedback. Okay. So feedback involves using past data and outcomes to improve current and future processes. Data, image data from AOI, X-ray images, failure pictures we share. Feedback, AI models analyze their data and identify defects. In fact, AI, what we call pictures are available, images. Within 4 minutes, suppose there is a failure in assembly, they compare this assembly failure with the previous failure and they say, is it similar or is it something different? Adjust
Hmm.
machine parameters, sorting temperature, sorting profile, component placement accuracy, refine AI algorithms for better defect detection, update design rules to prevent recurring defects. So I told earlier, if a defect occurs at random locations in a PCB, it's a process defect. And if a defect
Hmm.
occurs at the same location in all the PCBs, it is a design defect. Okay. Example, if an AI model consistently flags a specific solder joint as problematic, the soldering profile can be adjusted. And the training data of the AI model can be updated using this new use cases, basically connected factory. If they change, they give the data back to the CAD designer. It comes through IPC, CFX protocol. And of course, this is a qualified entry and qualified exit. Everybody will not be able to export and import, but only a qualified personnel, registered personnel in the company can do it. Yeah. Next slide, please.
Process optimization.
Yeah. You remember when we did PCBs even sometime back, people used to charge non-recoverable setup
Yes,
charges. Even
that is
your
correct.
PCB cost was 1,000 rupees. Setup charge
Yeah,
used to be 30,000 rupees. And that too it is not
right.
recoverable. They used to spend this money on process data. But even
Right.
now, people charge, may not be as costly. It depends on the how many boards we are building, or what is the relation we have, and how much we can do negotiation. But still, people spend a lot of money on that. Data, machine sensor data, temperature, pressure, speed, throughput, yield, feedback, adjust machine settings for optimal performance, improve material handling and flow, optimize machine maintenance schedules. Yes, uh, in Bangalore, December 2 to December 31st is holiday. Everybody will go for a machine maintenance. I don't know, maybe
Yeah.
in US also it is like that. So
I
that is
think
where
it's
they do.
pretty
Yeah,
much all over the world because that's
yeah, it has
also
become
like
a
more
global
like a
event actually.
holiday. Yeah,
Yeah, yeah,
holiday,
that is used for
period.
maintenance.
Yeah, yeah.
And by analyzing the sensor data, AI can determine the optimum oven temperature profile for soldering, minimizing thermal stress, and maximizing the yield.
Hmm. Okay, let's
Yeah,
take a quick break here
yeah,
and then we'll
nice.
come back. Yeah. Welcome back to the talk show, Friday talk show of Global Electronics with your host Rajiv Kulkarni. Good morning, good afternoon, good evening, wherever, whichever part of the world you're watching this show. And Global Electronics' main goal is to bring the experts like one we have today, our guest from Bangalore, the Silicon Valley of India, and share their wealth of knowledge in the electronics manufacturing. And electronics manufacturing is a cumbersome processes, and definitely there are a lot of challenges. There are a lot of updating is required, lot of upgrading is required on the equipment side, on the process side, or on the technology side. So in order to share their knowledge, in order to uh, make other people learn from their wealth of knowledge, the little our attempt is to bring those experts on our channel and discuss on certain topics. So today we are discussing about the design for assembly principles, that is feedback and feed forward mechanisms in the design for assembly. And this is feedback and feed forward 2.0. There should be more coming in the coming few sessions, coming few Fridays. But today we have Mr. Ambaprasad, who is an expert in the design himself for the last 3.5 to 4 decades in India. So welcome back to the show, Mr. Ambaprasad, after this small break. And I will again share the screen and then we'll take it further. Yes, I think we should be good
The
to
next
go
slide,
with the full
43.
screen. Yeah,
Yeah,
here you
next
go.
page. Yeah.
Predictive maintenance.
Yes, it is exact opposite of preventive maintenance. Okay. So
Yes.
the title itself says everything. So predictive maintenance, machine sensor data, maintenance logs, historical failure, feedback. AI predicts potential machine failures and schedules maintenance proactively, so that you don't have to, your production will not stop. You have already hit your market, especially every country, the product launches or a product sales will be cyclic actually. For example, Black Friday sale and in US and in India, of course, we have Dasara and Deepavali sales. People don't want to, they want to produce as much as possible and sell in that time. That time you
Hmm.
cannot afford a machine failure, and before that, and the schedule goes out of scope or whatever. So predictive maintenance, reduce downtime and maintenance cost, improve overall equipment effectiveness. OEE is the buzzword. In fact, we pay for the machine time. Okay, it's almost like the people, faster you do. In fact, there should be no waiting actually.
Hmm.
You do one board, go to next board, next board, next board. It keeps moving forward. So there cannot be any lack of components or lack of precision or lack of tuning. It should not stop. Otherwise, it stops. Okay, it will have a very cascading effect. Example: AI can analyze vibration data from pick and place machine to predict when a motor bearing is likely to fail. This is not in the PCB. It is in the, for example, you have a PCB assembly machine. The assembly machine will have got a lot of sensors and motors and a lot of attachments. There is
Correct.
a wear and tear for them. Now, if they fail, yes, there can be a mechanical inaccuracies. There can be lack of alignment, or the enemy number one, ESD, machine induced DSD, is the biggest threat. So this can be stopped by
Hmm.
predictive maintenance. Next slide, please. DFX feedback, design for excellence. So sometime back, DFM means manufacturing of a PCB. DFA
Yes.
means assembly.
Yeah.
DFC is cost reduction. DFQ, uh, uh, there is a
Quality.
DFQ, quiet operation, designed
Yeah.
for quiet operation,
Yeah.
designed for quality. There are so many issues, designed for environment. But IPC and other industries now call us DFX, design for excellence, which contains
Design for excellence.
DFA to DFZ. Yeah, everything.
Hmm.
So,
Hmm.
manufacturing yield, defect rates, assembly issues, the feedback keeps coming from the machine. Feedback, this data is fed back to the design cycle to improve future PCB designs or future
Hmm.
revisions.
Hmm.
Identify design flaws even before they become a problem. In fact, you can do DRC. When we do DRC, we can feed this data into the CAD environment and we can fix this. Optimize the component placement for easier assembly, especially in analog circuits. Components are placed in all possible 360 degrees.
Hmm.
It's not only 0 and 90 and 180 degrees. It's placed in all possible angles to avoid the loops. Okay. Improve signal integrity and thermal management. Example, if a specific component footprint consistently leads to soldering defects, better you change the footprint in the design and go for a next revision. Yeah. Next slide, please. Now, this is
Feed
where we
forward
are
data.
focusing on feed forward. Feed forward in data management. Feed forward involves using predictive models and simulations to anticipate and prevent problems before they occur in downstream
Hmm.
activities. It is shift left or shift left of left. I mean, people, sometimes people will be sick. For example, you go to a cat person, he looks at the cat symbol and say, I will not place this till you get this corrected. So sometimes they are right. I have encountered this many times. So people thought I'm talking like an authoritative, sort of, but it is not true. This is, you have to be a benevolent dictator. Then only you can handle this. It is very difficult to
Correct.
convince people, especially if something is wrong. Okay, it's not an easy task. Okay,
Yeah.
then you have to break the bad news, and people will correct. And in fact, companies nowadays, if there is a problem in the data sheet and all, if you tell them, they earlier they used to give you mugs and t-shirts as a gift, but now companies started giving design kits, you know, to make it
Okay.
more useful. So people also are happy to get the feedback. Simulation and modeling, CAD data, material properties, process parameters. Feed forward, AI-powered simulations are used to predict thermal stress during soldering, even before soldering starts. Signal integrity at high-speed traces. For example, uh, let's say, I'm just giving an example. Whenever we do a backplane, we do it for the next generation. PCIe 6 they may do. Maybe all the design constraints are built for the next generation. Though sometimes some generation, if you are using a particular bus, its parameters are reverse compatible also, and they are future ready. Okay, so that's what it mean by signal integrity for high speed traces. Generally, it's a over design. Now it looks like a over design, but after 2 years, if you replace the chip with a higher signal speeds, it will work. It works like magic. Okay, that's feed forward data. Mechanical stress during assembly. This data is used to optimize the design and process parameters before manufacturing begins. Generally, even now, it is called as red, yellow, and green color. Red means it is a total defect. Yellow color means yellow or orange, they say. Uh, it is nice to improve, and green means there is no problem. So they come in 3 color codes. Simulation software can predict the temperature distribution during reflow soldering, allowing engineers to optimize their own profile and prevent component damage. Okay, so this is quite. There can be a something like a 16,000 pin BGA. Next to that, there will be a sensor which is only 8 pin. It's a thermal sensor. Now, by the time you assemble this huge BGA, okay, the thermal sensor is overheated in the profile. Okay, but your thermal sensor has to sit there only. You cannot move it far away. So these are the adjustments they have to do. Yeah. Next, predictive quality control, process parameters, material properties, and historical data, they're analyzed. Feed forward. AI models predict potential defects based on process parameters and material variation. Yeah, material variation will always happen. Okay, it can happen in laminate and prepregs, or it can happen in solder also. No problem. Adjust process parameters in real time to prevent defects. This is very important. It almost adjusts real time. Identify and reject potentially defective materials before they enter your supply chain. Okay, if there's a defect, don't use that material. Use some other material. By analyzing incoming material properties, AI can predict the likelihood of warpage during soldering and adjust the process parameters accordingly. So BGA warpage is the biggest threat. Every company had their own way of solving the problems. Some companies removed corner pins of a BGA because the warpage was happening at the corners. Some companies put a pillow at the corners. They used to put a small acrylic pillow. They were gluing it actually. These are some of the methodologies. Next. Uh, Digital twin, it's called as virtual prototype. So you do your simulation, your design, you build a digital prototype. It's just an image. And if you uh, go to a new vendor or a new EMS house, their process you can import and compare with the digital twin, you know, whether it will fit in yes or no, or how much process variations are there. Digital twin is a big business now. So all CAD packages, they're able to give you digital twins.
Excellent. So I wanted to tell the audience that Global Electronics brings these kind of topics every week. Request you all subscribe to the channel if you have not yet, and share the channel link to with your colleagues in the electronics manufacturing industry. Yes, Mr. Ambaprasad, please continue. Are you there?
Yeah, I'm very much there. I think there are only two more slides. You can just go
Okay,
to the next slide.
that's fine. Yeah, that's fine. I think we are almost through the time as well. So
Yeah.
AI powered process flow.
Yeah. So data, material property databases, environmental impact data, cost data, electrical properties, these are all disclosed under non-disclosure agreement. It's not
Yes,
available in the open.
that
Feed
is correct.
forward, AI can select optimal material for PCB based on performance requirements, cost and environmental impact. Uh, Given electrical performance requirements and environmental constraints, an AI can select the best material which is possible. Go to next slide, I think, which is the last slide for the day. Yeah, this is where your expert AI agent will help you. Maybe this can be a beginning slide for the next session. And
Yeah,
I have only now going forward, we can take one by one examples, feed forward and feedback, and maybe we
yeah,
can discuss at length how it
absolutely.
really helps. And this is
Absolutely.
a big, it's not only a big business, this is a serious business. This is as serious as 40 years back when people migrated to CAD.
Right, right, right.
So when people went into CAD, it created a big uh, in the market. There was a lot of turbulence in the market because of CAD. Either
Yes.
you do CAD, or if you cannot do CAD, yes, then that's it. So now
Yeah,
AI is taking that position. Yeah.
yeah.
Any
I
messages?
think messages, yes, whatever we had a couple of questions in the middle, we got over that. And I think it has been an excellent presentation, I would say, about feed forward and feed back. But why these are so important in the electronics manufacturing?
Uh, because if you, for example, I'll just give an example. Let's say I'm talking about feed forward. Why feed forward is important? I can just,
Yeah, yeah,
before
feed forward.
you,
Yeah,
yeah, before you manufacture a chip, you manufacture a chip, okay,
yeah,
a server class chip, GPU. The GPU is tested on a test board. Okay, test board is also a PCB. When they do the test on the test board, they know the process window, they know the corner cases, they know everything. They tell
right.
you, can this perform at such a speed, so many Gbps, and
Mm-hmm.
such a power, so many picojoules. I mean, people are
Mm-hmm.
talking of picojoules per bit. Now, if they find there is a small adjustment needs to be done in the actual live product, they give you some data as a PDK or a ADK. ADK is assembly design kit and a product design kit. And they say you have to do this. If you don't do this, I cannot guarantee the performance of the product. That is feed forward. Okay.
Hmm.
Yeah, this is like prediction. Okay. I mean, if I will give you just an example, even before going to exam, at least I found in Bengaluru, people go to Ganapati temple and say, they even, so that is, something, there is something, I can't say divine, I can say something beyond physics in all this.
Yeah,
In the
yeah.
process, there is something physics, which is multi-physics. Okay. You try to fix something, something goes wrong. So all this will coalesce if we follow the feed forward and feedback properly.
Wow. In fact, someone has commented very nicely saying that it's quite enlightening. So I think your all sessions are enlightening, Mr.
Yeah,
Ambaprasad.
that's good.
I definitely say that because you come up with such a very interesting and active and proactive measures. I would say what is exactly is happening in the electronics industry, and also mainly considering the design perspective as well as manufacturability. So, ladies and gentlemen, if you haven't subscribed the channel yet, please do subscribe because we have many sessions which we have done in the past that you are able to watch that because they are all there, recorded ones on our YouTube channel. And then we will be coming out with more sessions. And next week again we will have Mr. Ambaprasad presenting another topic on the same feedback and feed forward. why it is so important in our design for assembly in the electronics manufacturing. So, Ms. Ambaprasad, you have any message for our audience before we wind up for today?
I have one important message.
Yes, please.
In fact, maybe the person who taught me this process, feedback and feed forward, maybe he's still watching this. I don't know, but I may
Okay.
watch it later. In
Okay.
1984, when I did
Uh-huh.
my first 386, not 386, 80, 85, 82, 86 machine, it was a manually done
That
layout.
time it was 286, right?
286.
Yeah.
Manually done layout, not a CAD, manually done layout. My
Right.
DFM guru, DFM used to be like this. We have a layout. On layout, we put a tracing sheet. He comes with a red and black pencil, and he will mark in circles on tracing sheet telling this will work, this will not work. This was feedback, feedforward was there even 40 years, 50 years back. But
Back.
now it has become an engineering. That time it was magic. Little later it
Yeah.
became science. Now it is engineering. Yeah, that's it.
Wow. Excellent. Excellent message. Thank you, Ms. Shama Prasad, for your valuable time. Next week, again, we will have you with that another session. And thank you all for watching our show and commenting as well. Please do watch. It will be there on our YouTube channel forever. As well as also, I would say that if you have any topic in your mind, you can post it very openly without any problem, that we can also discuss about that topic. And if you want to participate in our YouTube channel live talk show, please do send a message, and definitely we will discuss with you, and we can select the topic of your interest, and you can also come on the show and have a live talk show like this. With that said, your host Rajiv Kulkarni will take leave at another week now, and have a great weekend. And thank you all, and have a great rest of the day and rest of the night, wherever you are watching the show from. Thank you again, and God bless. Bye now.